Hi everyone, let's now do translations using coordinate shifts. We're going to go back to an old example from section 0.13 on circles. And these techniques will work even for graphs that fail the VLT and situations where we don't have y as a function of x. So here we have the graph of x squared plus y squared equals 9. It's a circle of radius 3 centered at the origin. Now, in order to move the graph to the left by 2 units, meaning that the center also moves to the left by 2 units, we substitute or replace x with the quantity x plus 2, not x minus 2, x plus 2. So just like we've described before, the signs are surprising. We've seen that before for horizontal shifting. But now look at this. In order to move the graph up by 1 unit, in particular, in order to move the center up by 1 unit, we substitute or replace y with the quantity y minus 1, not y plus 1, y minus 1. So the signs are surprising for both horizontal and vertical shifting. The signs are surprising for both horizontal and vertical shifting. The signs are surprising in both the x group and the y group. Remember, the general form for the standard form for the equation of a circle is given by x minus h all squared plus y minus k all squared equals r squared, where hk is the center of the circle. Pretend that's a circle. Pretend that's the center. Here's hk, the center of the circle. All right. Again, to translate h units horizontally, if h is negative, you go left. To translate k units vertically, if k is negative, you go down. You substitute or replace x with x minus h and y with y minus k in parentheses or grouping symbols. That's the general principle I articulate in this box. And in fact, if you go to Desmos, if you consider x minus h all squared plus y minus k all squared equals 9. Right? Let's add sliders for all h and k. Right? So if h is adjusted, we shift horizontally. If k is adjusted, we shift vertically. Hey, instead of 9, let's have r squared. Let's add the r slider. If you shift r, you change the radius. So together, by sliding around h and k and r, you can get all possible circles in the the xy plane. All possible circles in the xy plane. You can get by getting various values for r and h and k. R should be positive. But every circle in the xy plane will correspond to some values of r, h, and k. Keep on sliding. Keep on growing and shrinking. All possible circles in the xy plane. All right. Now, this is actually all consistent with what we've done earlier with functions. This is a generalization, but let's look at an example. Example 12. Let's look at this parabola, the graph of y equals x squared. Let's say that we want to shift this parabola to the right by 2 units and then up by 1 unit. So to shift the graph to the right by 2 units, we substitute x, we replace x with the quantity x minus 2. Remember, it's not x plus 2, it's x minus 2. The sign is surprising. But by using the technique I just mentioned, if I want to shift the graph up by 1 unit, I substitute y with not y plus 1, but with y minus 1. I could put grouping symbols here, but that's not necessary. This is all alone out here. So by doing that, we get the corresponding parabola over here, shifted to the right by 2 units and up 1 unit. The vertex moves from 0, 0 to 2, 1. I guess I should have the horizontal shift in red. But how's this consistent with what we've seen earlier in the section? Well, like we said before, for a horizontal shift, the sign is surprising. Also, you substitute. You substitute x with the quantity x minus 2, not x plus 2, x minus 2. But now, look at this. If you add 1 to both sides of this equation up here, if you add 1 to both sides, then you just get y all alone on the left side, and you get this very normal looking plus 1 on the right. So when you add 1 to both sides of this equation to this equation, which looks more familiar to us from earlier in the section, basically we're going from a situation where the sign is surprising. Up here, the sign surprises vertically. The sign surprises vertically at first. But then over here, the sign is predictable. The sign is as expected. So up here, the sign surprises. To move up 1 unit, you substitute or replace y with y minus 1. But over here, after you add 1 to both sides, over here, well, if you want to move the graph here up by 1 unit, you attach a plus 1 to the right side. So that's why the vertical shifting makes sense. The signs are as expected. The horizontal shifts are still surprising because that's still a residue from what we did up here. We'll talk more about parabolas in section 2.1.